right. So, no worries. No worries, no worries. So first thing we're going to do is just go through, well, any questions about the tests? Test 3? No. Yeah. So, yes, of course you can. I know, right? Okay. Review day 1 of 2. Which makes me sad because it means we're done. I don't get to see you guys anymore. Who am I kidding? I think we're all a little excited, but I'll still miss you guys. Okay, so yeah, if there's no questions about that test 3, then we'll just get right to it. So final exam format. Okay. The first question is going to be short answers. Okay. So 20 marks worth of short answers. Some of these short answers are going to be 2 marks. Some of them are going to be 1 mark. Okay. So short answer for 20 marks. Okay. So just quick little ones, right? We've seen short answers from test 1, test 2, test 3. It'll just be kind of from those types of short answers, right? Just little, like now I think you have a pretty good idea of what I mean by a short answer. Just quick little things that we might have covered, right? That don't really warrant a long answer, right? And so that's all I mean by that. And then we're going to have long answer questions. So long answers, they're going to be 10 marks each. So for question 2, let's call it, right? The first long answer is, and you'll notice that we just make our way through the formula sheet. There's going to be 1 long answer on merchandising, then 1 long answer on CVP analysis, etc. Okay. But so it's going to be on merchandising. Which we saw in test 1. Okay. Question 3, second long answer, gets confusing, is going to be on CVP analysis, which are profit functions, right, where we had to build the profit function, also on test number 1. And then we'll move on to simple interest. I think you'll be happy to know that there's no linear programming on the final. Right, we had that big linear programming question on test 1. You don't have to do it on the final. Those days are behind you. Okay. So just merchandising and CVP analysis, right? That's from test 1. Yeah, where we had to draw the straight lines and figure out and maximize the, yeah. So I think everyone's a little happy about that. I throw it in there because it's supposed to be fun and easy, but People don't like it. So it's not on the final. So a simple interest problem. Yeah. So simple interest. Even though you might be tempted to try to use your calculator for simple interest problems because it doesn't say you're not allowed to use your calculator, we can't, right? The calculator can't do simple interest. It can only do compound interest. So you have to do it by hand. But once we go through the example, you're going to say, what was the big deal there? Nothing. Right? Now that we've worked ahead so far. Simple interest was on test number 2, right? So I'm giving you all these test numbers so that, right, you can look at everything related to test 2, right? You've got a practice test, you've got some written assignments, right? So we've got lots to go off of. So just a simple interest problem. Thank you. Nope, I'm just saying these are the long answers. They're 10 marks each. First one is going to be merchandising. Then CVP analysis is a second long answer question. Then simple interest is a third long answer question, and so on and so forth. Okay. There's 2 questions on compound interest. Okay, the first one is, so compound interest. Where you have to calculate some unknown payment amount. You saw that on test 2. For that one, you're allowed to use your calculator, right? The built-in calculator functions, or you can do it by hand. I'd probably just do it by hand because, I don't know, I think it's easier, but it's up to you. Next question is also compound interest, but you have to do it by hand. Okay. So compound interest by hand. Okay. So same thing from test 2. Oops. Things got a little rugged over here. So that one we have to do by hand. So then, right, just notice how we're working through our formula sheet, right? Question 1, question 2, long answer, question 3, long answer, question, 4 and 5, long answer, and then we move into annuities. Right? So then we have to do an annuity by hand. I've warned you that we were going to have to do an annuity calculation by hand, but the rest of them you can use your calculator. Okay, so annuity by hand. It's like test 3. And the next one is going to be another annuity, but you can use your calculator. Okay. So annuity may use calculator, and actually I probably would. Because what it's going to be is it's going to be a 3-part, just stepping it up from test 3. So the last question on test 3, right? You had, Okay, so he's making payments, and then he goes to, right away he transitions to getting payments. What if we put a space in between, right? Then we've just got compound interest in the middle there, right? So we're just kind of spacing these out. So he's making payments for 10 years, and then he's letting it sit for 5 years, and then he's getting payments, right? We'll look at an example. Okay. So I would call this a 3-part problem instead of the 2-part problem that we saw on test 3, but it's kind of a natural extension, right? You just add this one little calculation. What's nice is on test 3, right, you had to do by hand. Now you can just use your calculator, figure out these amounts, and it won't be nearly as hard, right? So this one's going to be a 3-part problem. So something like making payments, letting them sit, then getting payments. Basically the same as test number 3. And then the 9th question, or the 8th long answer question, is another annuity, but it's going to be a deferred annuity. And I'll even tell you this. You have to find time. So the situation is, it's going to be a 2-part problem. Initial investment. So you're going to have some initial investment that sits there until it's grown to some amount that can sustain regular payments. We didn't see this on test 3, but we did do one in class. Right. So you've got some initial investment that sits for an unknown time. Right, that's what you have to find for, or find. To sustain specified payments. And we did this in class. But notice, I'm not saying you have to do it by hand. You're allowed to use your calculator for this one. Right. So there's really only 2 that you have to do by hand. The 5th and 6th long answer questions. The rest you're allowed to use your calculator as best as you can. Finally, the 10th question, 9th long answer, is on mortgages. Right. Exact same setup as your written assignment 3 that you just did. Right. And so you have to find the payment amounts, and then you have to fill in the table, and then you have to calculate how much interest was paid. That's it. Right. So mortgages, like written assignment 3. And that's why I wanted you to hand them in today. Usually I give you a whole week to work on stuff, but I wanted them in today so that I can return them on Wednesday, and then you'll have them, right, for study. Yeah. So the total is 110 marks. So obviously you'll want to focus on these long answers, right? 90 of these marks are in the long answers. That's also where I can give part marks more than the short answers. Right? Okay. Some of them are just 1 marks. Yeah, 1 mark. So it's a fun mix. I think we have to have at least 5 2-mark questions. There's something like that. So just yeah. Okay. As far as office hours go, our final isn't until the 18th, right? So I will have office hours for my other class, so you're welcome to stop by then. I'm having all day office hours. All day office hours. So 9 to 5. On December 12th and December 18th. What? That's the day of the final. I know, because I'm on to you guys. That's when you're going to have questions. Of course. And so I'm flying in on the 11th and the 17th. So I'm available. Yeah, I'm going to Ottawa. I'm available in the afternoon of the 11th and 12th in person, or quite literally always by text to 50864-8386 or email ely@okanagan.bc.ca. Oh, that's an E. So many E's. So you can always ask me questions, right? If you're working on something and you send me a picture and you're saying, hey, this looks weird, what's going on here? Then I can usually kind of quickly decipher it, get back to you. Okay? So, and if you want to talk, then we can meet in the Zoom room, which is also fun to say, and go through it there. Okay? So, got options. Any questions? Yeah.
Is your final exam in this class?
No, our final exam is on, I'll just write it all out, December 18th at 6 to 9, which sucks, in S104, right? Which is that huge auditorium. And it's actually not just us in there. It's going to be you guys, my other section, Steve's section, and Steve's other class. So it is going to be a bit of a mess. And so, and of course it's kind of auditorium, like theater seating. So there's going to be a lot of, excuse me, coming through, excuse me, sorry, yeah, blah, blah, blah. Makes going to the bathroom a little bit tricky. Try to avoid it if you can. Right. And so what we're going to do is we're going to post ahead of time where you'll be sitting. And then hopefully that'll kind of alleviate all the mess that will be this room. Okay. I guess, yeah, as you might have noticed, scheduling was a little bit off this term. So they just said, okay, well, if everyone has to write at this time, everyone's going into this room. Okay, great. So we are in S104, which is just in the student services. I don't know if you guys know where it is. It's kind of hidden, but it's actually a huge room. So yeah, kind of like down, yeah, basically. Yeah. Yeah.
So you have those where we sit on my Google?
Yeah.
So is the formula sheet to we provide?
I will give you the formula sheet, but again, just like the test, it'll be the exact same one that you're used to. In fact, I'll just be reusing those from the test, of course, so they'll look familiar. Yeah, so you have 3 hours. Use them wisely. Any other questions before we start this review? Oh, great. I need to change the setting. Second to last day of classes, that's when I'll change the setting. Thank you. Okay. So I did post the practice final, but I just posted it this morning, so my apologies. But we'll start and we'll work through the long answers, and then whatever we get through is good, and then next day we'll pick up on the long answers, and then if there's time, we'll go through those short answers. Otherwise, just like the test, I'll just post the solutions. Okay. So let's see here. Oh, there it is. Beautiful. Okay. Oh, don't need to look at the. So here in the square brackets, you've got the number of marks that they would be worth. And so 1 mark, 1 mark, 2 marks. Just kind of. And then I decided to be nice, and for these ones that you could do on your calculator, just like on test 3, I've given you the little field to fill in, and if you fill it in correctly, even without calculating, you get a mark in a, well, I guess in this case, 0.75. You get 3/4 of the marks. Okay. So, like I said in that message that I sent out, I didn't print the practice tests. We'll just read them closely together, and then I posted it on Moodle. Just because it's really long, because I wanted to give you an idea of also the space that you have, right? So you can print it off and actually work through it. Okay. Okay. I'll just copy all of this. So we'll start from the beginning. These question numbers are a little bit weird looking just because each of the short answers got a number, but this would be our merchandising question. Oh, and don't worry, the list that I gave you, right, that is the order that you will see these questions in, right? So they're not going to jump around or anything. They're going to be in this order, I promise. Okay. So we start with a merchandising question, move into CVP analysis, right, move through our formula sheet. Okay. Remember this stuff? Yikes. An RV dealer purchases stock for $138,423, less 39%. Right, so we've got this discount rate of 39%. The dealership marks up 25% of costs for overhead and 35% of selling price for profit. Okay. During a sale, this particular model of car, although I suspect it's an RV because it's an RV dealer, doesn't matter, was advertised at $119,995. Right. So we're given the reduced selling price. Determine the cost, the selling price, and the rate of the markdown during the sale. Okay. So we've got a couple of things that we need to figure out, but we're gonna start by just figuring out what we have. Oh, you can go from there. Okay, great. Luckily I have to find my solutions here, so I don't forget to tell you guys anything. Okay. So what do we have? So the RV dealer purchases stock for a list price. So this is where we have to keep track of what all these letters are, right, in the merchandising section. Once we have the letters and what they're worth, right, then it's going to be easy to figure out the rest, but probably the hardest part is figuring out what we're given and what we need to find. Okay. So the list price, right, if you're looking at the net price, is the list price times the discount, right, 1 minus D. In this case, we're told that the list price is 138,423. So let's write that down. 138,423. And we're told that the discount is 0.39. We're also told that the dealership marks up 25% of cost for overhead. Okay. So we're told that the overhead, which we had E, right, the overhead expenses, we don't want to use O, it looks like a 0, it gets confusing. So we have E is 0.25 of the cost, right, 25% of the cost. And 35% of the selling price for profit. So the P, profit, is 0.35 of the selling price. During a sale, this particular model of, I'll change it to RV. Yeah. Oh, Calvin, do you have a question or no? Just a classic stretch. Yeah. Quite all right. It was advertised at $119,995. So bless you, the reduced selling price is $119,995. And we want to find a couple of things here. Find C, find S, and the rate of the markdown. ROMDA. Okay. So we've got all this information, right? And so, all right. We want to find C and we want to find S. First thing is we have to remember that C, right? C is the cost to the dealership, right? Which at the dealership level is the same as the net price. So C, finding C. C is the cost to the dealership. Which is going to be the same as the net price. To the dealership. Good. So essentially we just have to find the net price. Right? The tricky part was making the link between, okay, well, C is the cost of the dealership, right? N is how much the dealership paid for this product, right? So those must be the same, right? And so N from your formula sheet is the list price times 1 minus the discount, or even if you have multiple discounts, right? 1 minus D1 times 1 minus D2 times 1 minus D3, etc. Okay. But in our case, we just have one discount of 39%. So we have the list price of $138,423 times 1 minus 0.39. So 138,000, oh, I'll do 1 minus 0.39 first, times 138,423. So they paid $84,438.03. Therefore, the cost must be the same, 84,438. Oops, makes my numbers up. Not ideal when you're doing math. 84,438.03. Yeah. Great. So we found costs. It's safe to say that I'm going to give you these values in the order that you're going to want to solve for them. Right. Let's see if we can find S, right, given the information that we have, because now we have C, right, and we have all this other information. Right? We have C, we have E, we have P. Hey, it looks like S is C plus E plus P, right? So we can use that to solve for S. So finding S, right? Now we know C, E, and P. Right? So we can use S is C plus E plus P. To find S. So S is going to be, so the cost we know is 84,438.03 plus E. There's a couple of ways that you could set this up, right? Because E is 0.25 of the cost. So whether you wanted to write it in terms of C and then collect like terms, or if you want to just do a little bit more math, that's fine too. You know what? Let's do it in general first. Show off a little bit. Just keep it as C, even though I know what C is. And you don't have to, like I said, there's a couple of ways that you could go about doing this, right? But if we want to just collect like terms and do less math, this is the way to do it, right? C, and then E was 0.25 times C, and P is 0.35 of S. So 0.25 C plus 0.35 S is S. All right. So way back, feels like forever ago, right? We did lots of these together, right? Where we're gonna collect like terms. So we've got S on both sides, so we're gonna bring the S's over to one side, the C's over to the other side. We know what C is, right? So then we can plug it in, solve for S. So we've got S minus 0.35 S is C plus 0.25 C. So we've got 1 minus 0.35 S. That makes 0.65 S. Right? You have to remember that 1 in front of the S on its own. Right? Same with the 1 in front of the C. Collecting like terms, right, we get 1.25 C. 1C plus 0.25 C makes 1.25 C. So 0.65 S is 1.25 times C, which we actually already know, 84,438.03. So then we have 1.25 times 84,438.03. 105,547.5375 is 0.65 S. To solve for S, right, we have to divide both sides by 0.65. So then S is 105,547.5375 divided by 0.65. So S must be 162,380.8269. So the selling price is 162,380.83 pennies. Okay. Great. Now we found S. Last thing we're going to find is the rate of the markdown. Right? The rate of the markdown shows up twice on your formula sheet, right? So if you know the amount of the discount, D, you can divide it by S, the original sales price. That's one option. You could find the amount of the discount because you know the reduced selling price and you know the original selling price, right? So the difference between those two is the amount of the discount. Or if you did SR is S times 1 minus the rate of the markdown. To me, that's a more obvious choice just because I have the reduced selling price and I have the selling price and I'm looking for the rate of the markdown. Whereas if I had to calculate D, right, that's not completely obvious right away, right? So I'm going to use that first option, but they both work. So finding the rate of the markdown, you can use the reduced selling price as the selling price times 1 minus the rate of the markdown, or the rate of the markdown is D over S. Or you can use either of those. But I'll stick to that first one. So the reduced selling price is the selling price times 1 minus the rate of the markdown. And we're trying to find the rate of the markdown. So the reduced selling price, I have it here, is 119,995 is S, which is 162,380.83 times 1 minus the rate of the markdown. We're trying to solve for the rate of the markdown, right? First thing we have to do is divide both sides by 162,000. So 119,995 divided by 162,380.83 is 1 minus the rate of the markdown. Okay. 119,995 divided by 162,380.83. So we have 0.738972698 is 1 minus the rate of the markdown. To solve for the rate of the markdown, right, you first have to subtract 1 from both sides, right? And then to ditch the negative, right, you're gonna have a negative number on both sides, so they'll just cancel out. Or technically divide by -1. So then you've got 0.738972698 minus 1 is the negative rate of the markdown. So -1. So I get negative 0.261027302 is negative rate of the markdown. These negatives just cancel. So therefore, the rate of the markdown is 0.261027302, or approximately 26.1%, let's say. And we found them all. 10 marks in the bank, right? Feels like forever ago, but there you have it. Right? And so if you look back at test 1, right, you're gonna kind of work through those, and especially if I ask you to find multiple things, probably find those in that order. Right? I'm trying to help you along. Okay. Okay. Any questions about that one? Great. Moving on to our CVP analysis. So here we've got our CVP analysis question. Right, that's going to be a profit function. Again, it's 10 marks. It's going to be multiple parts. So let's have a read here. And we saw one just like this on test 1. So Walmart plans to sell 200 barbecues next week. Good luck in this weather. At an average cost of $278 each. Their weekly staffing expenses are $19.45. How much must they charge for each barbecue to break even? Also, I don't know if those staffing expenses are reasonable. Doesn't matter. Right. So we've got some cost and we've got some expenses. And then I ask you, how much must they charge for each barbecue to break even? Remember, breaking even is where you have covered your cost, right? And so we have to develop our profit function. So, let's figure out what we've been given first. So we've been given that the number of barbecues that they want to sell is 200. So we're going to start with that and say that, okay, well, X, remember from your CVP analysis, X is how many units were sold, right? How many you plan to sell. So X is 200 barbecues. We're also told that the cost is $278 per unit. It has to be per unit. And we're told that the expenses in terms of CVP analysis, right, those would be considered our fixed costs, right? They have to pay their staff regardless of how many barbecues they sell. They still work that time. It's a fixed cost, right? So the fixed costs are $19.45. So first thing we're going to do is we're going to find the profit function. Because what do we need? For the break-even point, right, where we've covered all our expenses, the profit is 0, right? Because break-even is when profit is 0, right? So that's why we have to first find the profit function, and then we can find the break-even point. From our formula sheet, we know that the profit of X is just starting from, remember we kind of snake our way through kind of backwards, right? We start from the basic profit function, which is just the total revenue minus the total cost, right? And then we say, okay, well, the total revenue is the price times however many units we're selling, right? And we just kind of slowly pull things in, but we start from the very basic total revenue minus total cost. And then we work our way up. So where the total revenue, we can replace it with PX. I'll do it in many steps because it was a while ago. So you can replace the total revenue with P times X. And then the total cost, right? The total cost is P times X minus, and then the total cost is the first thing on your formula sheet, right? Just the variable cost plus the fixed cost. It's important that you put these in brackets, right? Because that is the total cost and we have to subtract all of it. So the total cost is the variable cost plus the fixed cost. Where we can finally replace the variable cost with C times X. PX minus C times X plus the fixed cost. If we break out the brackets, right, or if we expand this, we get PX minus CX minus the fixed cost. And that was one of the things that I remember seeing on test 1, right? You forgot to make the fixed cost negative once you busted out those brackets, right? So I want to see those expanded. Now we can collect like terms, right? We've got X times P minus C minus the fixed cost. In our case, so we want the profit to equal 0, right? And the question said, how much must they charge for each barbecue, right? That's going to be your P. How much are they charging per unit? So we want the profit to be 0 and find P, right? The price per barbecue. So we know a lot of these things, right? We know we want the profit to be 0. Okay? So profit on the left-hand side is going to be 0. X, we're told they're going to sell 200 barbecues and they just know it. P is what we're trying to find. C is the cost, which we were told was $278. And then finally, the fixed cost was that staffing amount, the $19.45. Right, so we have all these things. Now we can find the price for the break-even point. So we know just to, I'm just rewriting the profit function down here so I can fill it in. So we need the profit to be 0. X is 200 times P minus, what was it, 278? Minus 1945. So now we can just solve for P. And so we're going to move the 1945 over to the left-hand side. So we get 1945 is 200 times P minus 278. We have to divide both sides by 200. 1945 divided by 200 is P minus 278. So 1945 divided by 200 9.725 is P minus 278. I have to add 278 to both sides. So 9.725 plus 278 is P. 278. 287.725. Guess it's not a dollar amount quite yet. They must charge $287.73 per barbecue. Oops. To break even. What you'll notice is that this one, out of the 10 marks, finding the profit function, that's a lot of work, right? Later on, the rest of the questions aren't that much work. So a lot of these marks are going to come from developing the profit function, of course. Okay. So how about part B? Now that we have the profit function, this one's a breeze. If they wish to make a profit of 1,500, so no longer 0, right? They don't just want to break even, they want to make some money. So they want to make a profit of $1,500. Then what price do they have to charge? So the exact same question, just instead of a profit of 0, now we want 1,500. Right, so we can just steal the same profit function from before. Profit of X is I'll do the general one, X times P minus C. Actually, I'll steal from here, this one. Oops. That way I don't have to put it in all the time. It's actually easier on your page because you just have it up above, right? Where we said that, okay, well, the profit of X is 200. Where did I put it? Times P minus 278 minus 1945. All right, you can start there. So now we want to force the profit to be 1,500 is 200 times P minus 278 minus 1945. Same thing, right? We're going to add 1945 to both sides, so we get 1,500 plus 1945. I'm not going to show quite as much work. 3,445 is 200 times P minus 278. So then divide that by 200. I get 17.225 is P minus 278 plus 278 to both sides. P must be 295 0.225. They must charge $295.23 with rounding. So like I said, once you have that profit function, then the rest of the questions are a little bit easier. How about question C? So now it changes the scenario a little bit, right? Because now if they sell 90 barbecues at $400 each, how much profit will they realize? Right, so now X is 90 and P is 400. So now we have to change our X and change our P and figure out what's the profit. So we have a profit of X, which is X times P minus C minus the fixed costs. You can just start there. X now is 90 times P, the price they're charging is 400 minus 278, right, the cost to them per barbecue, minus the fixed cost of 1945. Bed mass applies, right? So we have to do 400 minus 278 first, times 90. We get 10,980 minus their fixed cost of 1945. $9,035 would be their profit in that scenario. Right? They would profit $9,035. Of course, on the final, if you just have your answer, right, profit equals $9,035, you don't have to write a little blurb. I just like to tidy it up. Cool. I'll put the next one. Just going on and on. So now we've got this other scenario. If they sell 100 barbecues, right? So now X is 100. Through a special promotion, what's the minimum price they could charge to break even, right? So find P. And remember again, break even is where the profit is equal to 0. Right? So we can say, okay, well, the profit of X is X times P minus C minus, I'll put the general one down. We're forcing the profit to be 0. And we're forcing the X to be 100. We want to find P. C is still 278. And our fixed costs are still 1945. We're solving for P again. So we have to add 1945 to both sides. Is 100 times P minus 278. 1945 divided by 100. 19.45 is P minus 278. So P must be plus 278. 297.45. Yeah. Minimum price for break even would be $297.45. Yeah. Oh, so yeah, because I didn't show all my work. So I had to add 1945 to both sides, right? And then I had to divide both sides by 100. So that's how I got to the, yeah. And then I had to add 278 to both sides. So this one might sound a little bit weird because we haven't done this in a long time, right? But what market conditions would force Walmart to stop selling barbecues in the short run, right? This is the same as saying, what is the shutdown point? What's the definition of the shutdown point? It's when it costs more to produce something than you're selling it for, right? So the shutdown point is when P minus C is less than 0, right? Or if you want to just say when P is less than C, so if the price that they can charge is less than C, which is $2.78, they must shut down. And of course, just the sales of the barbecues. Right. So all I would be looking for, right, is that P less than 278. That's our shutdown point, because they had to buy this barbecue for 278. So if they had to sell it for 260, that doesn't make sense, right? They're just not going to sell it at all. Okay. Cool. So that's a long one, right? But once you've developed the profit function, yeah, it's okay, right? Just keep finding P different ways. Right. Any questions about that one? Oh. So judging by your list, right, that I gave you, this must be the simple interest problem. And sure enough, it is. Just make a note here. This is going to be simple interest. Which is going to feel like child's play compared to what we have been doing, but that's always nice, right? I took out a series of loans, so $4,000 on September 4th, 2004, a loan for $10,000 on December 12th, 2004, and a final loan for $2,000 on February 13th, 2005. What total debt do I owe on June 6th, 2005? Assume that I was charged 7.5% simple interest on all of the short-term debts. Okay. So first thing you're going to want to do is figure out, okay, we know we have to have one long answer that's simple interest. Or if you can't remember the order, then you have to read the question and figure out, okay, it's not compounding, so it's simple interest, which means we have to stick to this little section on the formula sheet. Okay. So of course we're going to do a timeline here, right? Map out all these dates. Okay. So we've got September 4th, 2004, December 12th, 2004, February 13th, 2005, and then finally June 6th, 2005. Right, so I'm counting 4 dates, so I have to have 4 ticks. Right. 1, 2, 3, 4. Okay, so let's put these dates on here. September 4th, 2004. And then December 12th, 2004. February 13th, 2005. And I want to know how much is this all going to be on June 6th, 2005. You guessed it. We have to figure out our days between dates. That's probably the tricky component of this question, right? Because simple interest is just simple interest. So we're going to put our dates up top and our loan amounts underneath the ticks. So let's just write out, so we've got 4,000, oops, there. A loan for 10,000 and a final loan for 2,000. And we want to know how much is this all worth on June 6th. Making June 6th our focal date. Right? Our focal date is where we're going to draw all these payments to. Right? We want to know how much is this all worth on June 6th. So if the arrow's going forward, we're calculating a future value. So we'll call that future value 1. And then second loan is going to have some future value 2. And then our third loan, or our first loan, I guess technically. Oh. Future value 3. These 3 added up is the total owing. For simple interest, we just need time, right? How long are each of these arrows? And so that's where the work is, right? Because we have to use the days between dates on our calculator, right? But let's call this time 1, time 2, and time 3. Just matching them up with future value 1, future value 2, future value 3. So time 1, we're going to say date 1 is, and remember we use month, dot, day, year. So date 1, in terms of this format, right, February 13th, 2005. So that's going to be 02.1, was it February 13th? Yeah. 1305. And then date 2. Date 2 is going to be the same for all of these, right? June 6th, 2005. So 06.0605. And then we want to find the days between dates. So I'm going to put a star there for showing our calculator work, right? I just show a little star for what I'm calculating. So I say, okay, well, the dates function, if I can remember, Oh yeah, it's over the 1. So second date function, it's been so long. 02.1305, enter. Right, so now it should be stored. And then you can scroll down to date 2, 06.0605, enter. Right. Scroll down, dates between dates, compute. I get 113 days. So as far as our time on our timeline, T is always in years. Right? So we have 113 out of 365. And I'm going to leave it as a fraction, mostly for space. And I'll probably keep it as a fraction in my calculations as well. All right, moving on to T2. T2, date 1 is the one we're interested in. So December 12th, 2004. So December is 12.1204. Date 2, we don't have to change, right? Because it's going to be 060605 throughout now. 060605. So the days between dates, if I just scroll up, so in the second date function, date 1 is the one I'm going to change to 12.1204, enter. Check that date 2 is still 6/06/2005. Days between dates compute, I get 176 days. So now T2 is 176 out of 365. T3, date 1 is the one that's changing. September 4th, 2004. 090404. Date 2 stays the same, 060605. Days between dates. It's the one we need. So I can just scroll up to my date 1 and change it to 090404, enter. Check that date 2 hasn't changed, and then days between dates compute, I get 275. So T3 must be 275 out of 365 days. We're going to say somewhere on here that the rate is 0.075. Right. For simple interest, that's all we need, just the rate, the time. And now, just becomes a matter of finding these future values. Okay. So the future value is P times 1 plus R times T. So future value 1 is P times 1 plus RT. The principal amount for future value 1, and remember I wrote my last one as future value 1, but the subscripts of future value 1, 2, 3 are just to tell me what order to calculate these things in, right? And so the present value, or the principal amount for future value 1, is 2,000. Right? So whatever's on the left-hand side of the arrow is the present value. On the right-hand side, you've got a future value. So you'll want to keep track of, so we always have this going on, right? We always have some P going towards some future value or vice versa, right? If you know the future value, going backwards to find the P or PV. So what did we say, 2000 times 1 plus R, which was 0.075 times 113. Oh, nice. 113 out of 365. So 113 out of 365 times 0.075 plus 1 times 2000. We have a future value of 2046.438356. So future value 1 in terms of money is 2046. Oh, my pen keeps erasing stuff. 44 cents. Yeah. Oh, this one? Approximately equal to. So it's just a squiggly equal sign. Approximately equal to. It's just me being picky because 0.438356 is not the same as 0.44.
I was never seen it written like that. I've only seen the bottom one.
Oh, yeah, that's just my unclean. The waves got a little choppy. Whoa. Does look like an X. Oh, well. So now we can find future value 2 just the same way. Future value 2 is P times 1 plus R times T. Only the principal amounts and the time are changing, right? The rate stays the same for all of these. So P for future value 2 is 10,000 and for 176 days. So we had 10,000 times 1 plus R, which was 0.075, times 176 over 365. So we got 176 over 365 times 0.075 plus 1 times 10,000. 10,361.64384. Try to clean up my act here. 10,361.64. Yeah. Ideally you would round up before, but it doesn't truly matter. So I guess the answer is no, not really. Future value 3. P times 1 plus R times T. 4,275 days. 4,001 plus R, which is 0.075, times 275 out of 365. 275, yep, divided by 365, times 0.075 plus 1, times 4,000. 4,226.027397, roughly 4,226.03. Question was, how much do we owe on June 6th? Total owing on June 6th is future value 1 plus future value 2 plus future value 3. Oops. Future value 1, I'll just steal it from here, 2,046.44 plus 10,361.64 plus 4,226.03, which, if I'm cheating, oops, $16,634.11. Whew. It's a lot of writing, a lot of days between dates, but not that much hard work. All right. Cool. Any questions about that one? No? So if you're looking at your list that I gave you of the types of questions to expect, right, after simple interest, we've got a compound interest problem with unknown payment amounts. This is what I mean by that, okay? And so here we've got compound interest with unknown payment amounts. A contract requires payments of $3,000 and $7,000 made in 2 and 5 years. Okay, that's your original contract. What 3 equal payments made today, 6 months from today, and 1.5 years from today are equal in value to that original contract? Assume that money earns 6% compounded biweekly. Right, so now we have compound interest. So we need to make our way to the compound interest section of our formula sheet. We don't have regular payments, right? If we had regular payments, that would be an annuity, right? If we had these yearly payments every year for 5 years, that would be an annuity, right? But here, because we've got a payment in 2 and then in 5 years, right? And then we've got 1 today, 6 months from today, and then 1.5 years from today. Because these aren't regular payments, it's not an annuity, right? It's just regular compound interest. Okay. So, okay. See what we've got here. So these get a little wordy, right? Because we have to keep track of all our dates. But once we can pin them down on the timeline, it's easier to keep track of, right? So we've got 2 and 5 years. Those are our first 2 dates. And then we're going to make a payment today, in 6 months, and then 1.5 years from today. So we'll start by making 5 ticks and go from there. So 1, 2, 3, 4, 5 ticks. So in order, right, the first tick would be today. And then the next tick, I think, would be, they're all before the original contract, right? The original contract wouldn't have a payment until 2 and 5 years. Right? So we'd have a payment today in our new contract, 6 months. So because all the other ones are in years, I'm going to convert that 6 months to half a year. Right? Just makes life easier. If you want to write 6 months, that's fine too. And then we've got 1.5 years. And then we've got 2 years. And finally 5 years. I'm going to add in here that we're going to use today as the focal date, right? It doesn't actually matter, but it's just easier to draw everything to one place. Right? And so I'm just going to draw them all to today, right? Your focal date is where you draw all your arrows to. Right? So you could have picked any one of these or even made up a 6th one, but I don't know why you would want to do that. You can, but don't. Okay, just pick one of those ticks and draw all your payments to that. Don't be a hero trying to make up a 6th tick. So I'm going to say use today as the focal date. I'll make sure to tell you what to use as the focal date, because sometimes that's hard to figure out, right? Where am I supposed to draw these? Does it matter where I draw them to, or maybe it doesn't, right? And so I'll make a note to add that and say, use this as your focal date. So that means we've got today as our focal date. And what does that mean? It means all our arrows have to go to today, right? They're not going to go anywhere else. So let's map out our original payment, right? And so we had payments of 3,000 and 7,000, made 2 and 5 years from today, respectively. Okay. So this is going to be worth some present value 1, and this is going to be worth some present value 2. Total value of original contract today. Right? Present value 1 plus present value 2. That's going to be the total of the original contract today. So whatever our new contract has to be, or is going to be, it has to have the same value today. Okay? So then we say, okay, well, we have to make payments, 1 payment today. So we're making 3 equal payments. You've seen trickier stuff, right? Where it was twice as much or 3 times as much, right? You make a payment and then you make another payment twice as much, things like that. Here we've just got equal payments, so that's nice. But you know how to deal with the other kind too. So now we're making a payment of unknown amount X today in 6 months and in 1.5 years. And there's lots of ways that we could show the timeline. I like to kind of keep them separate, but on the same line, like same timeline, so I can visualize it better. Okay. And so same idea, right? This second payment is going to be worth some present value 3, right? These arrows are all going backwards. So we're all calculating. We're calculating 4 present values in total. So this is the total value of the new contract today. The trick we use, right, is that we say, well, those totals have to be the same. Right? And that's how we're going to find these unknown payment amounts. Okay. So we know that the original total must be the same as the new total today. Sneak that in there. Today, or whatever focal date you use. All right. So for compound interest problems, we have to have the number of compoundings, right? If we don't have an annuity, right? If we just have compound interest, N is the number of compoundings, right? And so on our arrow, we just have N, the number of compoundings. So let's see here. So N is time times the frequency. And for this arrow, we've got 2 years. Time is always in years. Okay? And we're compounding bi-weekly. So F is 26. Right? So 2 times 26 is 52 compoundings. Next arrow, we can just fill in all the arrows. Time times the frequency. The length of this arrow is 5 years times 26. I have 130. The length of this arrow is 0.5 times 26, which is 13. Sneaking it in there. And here, N is time times the frequency, which is 1.5 years times 26. You get 39. And we know, right, that if R is 6%, 0.06, F is 26, I, we don't have I2, right, for this compound interest problem, so we just have to go to I, right, but we do have to calculate I, the periodic interest rate, is R over F, 0.06 divided by 26. I get 0.002307692. I'm going to store this in one. Because we'll have to use it for all these present value calculations. Okay. So we've got our time points, we've got our amounts, we've got the length of the arrows, the ends, and we have our I. Now we can actually do these calculations. So let's find our present values and see what's missing. Right? We don't have the X, and that's where we're trying to find eventually, or find ourselves maybe. So on your formula sheet, you know that the present value is the future value over 1 plus I to the power of n. So present value 1 is, I'll just steal it from here so I don't have to keep scrolling back and forth. Future value 1 is 3,000 over 1 plus 0.0023076992. I've stored that, right? To the power of 52. And I'll just steal it from here. $2,661.13. I've just rounded to 2 decimal places right away. Present value 2 is 7,000 over 1 plus 0.0023076992 to the power of 130. And 5,187.52. So now we know the total value today of the original loans, right? 2,661 plus 5,187.52. Right. Let's go ahead and find present value 3 and 4. Present value 3, we don't know the future value, but we know it's going to be x, right? And we just use x's for all of these because they're equal amounts. So x times 1 plus 0.0023076992 to the power of 13. Do you guys remember how we did this? Right, we found the denominator and then took 1 over that, right? And so we did recall 1 plus 1 to the power of 13. Right, so this is the same as x over 1.03041892. 1 over that is 0.970479075 times x. Right. So to get that 1.0304 from the denominator up into the numerator, that's the same as 1 over 1.0304, which is 0.9705, and then times x. Because we want to get everything on the same line is the goal. Okay. So let's do present value 4 has the same future value x times 1 plus 0.0023076992 times, or to the power of 39. And I'm just going to skip straight to 0.914025953x. I skipped straight. I went straight through. Recall 1 plus 1 to the power of 39. 1.0940608838. And then 1 over that. So we know, right, that the total original today, right, we've already said this, has to be the total new today. Which means that the present value 1 plus present value 2 has to be the same as present value 3. Oh, sorry, x plus I always forget that little guy. And I'm always kind of impressed when you guys remember it. On the flip side, I always forget it. X plus present value 3 plus present value 4. So now we have present value 1, which was 2,661.13 plus 5,187.52 has to equal X plus 0.970479075X plus 0.914025953X. Got a little cramped. Don't worry, I'll condense it here. This is the same as saying 7,848.65 must be the same as 2.884505,028 times X. So X, which is our equal payment amount, right, must be $2,720.97. That's probably good. So we'll just keep going through this practice test on Wednesday, and then you'll have seen it all. Okay. Cool. See you then. Make sure you get assignment 3 in. And if you didn't get your test back yet, come grab it.